you can decide if you're going to write down all of the equations in your notes for today. You have them in your notes from the previous days for ellipses and hyperbolas, and you can get them from the book or from your other sets of notes as well. You know, the equation for the ellipse and the hyperbola is very similar. So we had talked about when we wrote the equation for the hyperbola last week, what was like the major difference that we saw. And one of the major differences between the ellipse over here on the left is that those are all added. And then what we've talked about a few times for the hyperbola is that those equations, you're going to see subtraction. We also talked about some differences in the equations. Usually for the ellipse, you leave the numerator alone. It's always x minus a squared over something plus y minus k squared over something. And your denominators are switching, right? Your a squared and your b squareds. And we had talked about with the ellipse, a squared is always bigger. So if you have an ellipse on its side, you're going to put a squared underneath x. If you have an ellipse that looks like it's standing up tall, narrower, you're going to put a squared under y. For the hyperbola, the big difference was a squared and b squared don't move around. A squared is always first. So whatever you decide is your a value in a hyperbola, that always goes under the first fraction. It's really the numerators that flip-flop so that you can decide if your hyperbola opens up or down, left or right. We also know some things like A represents the distance from the center to a vertex in both of those, the ellipse and the hyperbola. In the ellipse, we specified that as a major vertex, so it was the vertex that was further away. C is the distance from the vertex to the foci in both of those. In the ellipse, the foci should be less than A. In the hyperbola, the foci value should be greater than A because they're like outside so that the hyperbola can open around it. And we know that like those equations, c squared equals a squared minus b squared, c squared equals a squared plus b squared, those are fair game to use to write the equation. And then the other thing that I have over here on the sideboard is your asymptotes for a hyperbola. Note that in the asymptotes, you've got, of course, the center point if you leave it in Poisson form. But probably the most important thing for these writing equation problems when I give you characteristics is if I give you asymptotes, pay attention to their slopes. Because their slope, we know, depending on the orientation of the hyperbola, is either going to be a over b or b over a. It depends on, like, is my parabola open up or down or left or right. So I'm going to do an example with the asymptotes just to kind of, like, talk about that. But those are all things, like, all that stuff that we've talked about with ellipses and hyperbolas, we can put that all together and use it to write equations. So here's the first one that I'm going to do with you guys, and then I'm going to let you do it on your own with your pods. You guys can work at your own pace. You can talk things out with each other. That's going to be super beneficial for tomorrow's quiz. Like, am I ready? Do I know what I'm doing? We're going to find the standard form equation of the hyperbola with vertices at 3, 0, and 3, 6. And the asymptotes are at y equals x and y equals 6 minus x. So you know me. I'm going to start all these problems by drawing a little picture. And I'm going to start with these 2 points, 3, 0, and 3, 6. And I'm told in the problem that those are vertices. So I'm going to go ahead and label them with B so I can kind of keep track of that. Well, those are vertices of a hyperbola. So by plotting those two vertices and seeing that they lie on the same vertical line, I now know my hyperbola opens up and down. Right? If the vertices were on the same horizontal line, they'd be opening left and right. Okay? So I'm going to go ahead and in blue, I'm going to draw my picture of my hyperbola. well, if I'm thinking about that in like the previous slide, what does the equation of a hyperbola look like when it has a vertical transverse axis? That's when y squared is first. So I know it's going to be y minus k quantity squared over a squared, because a squared is always first in a hyperbola, minus x minus h squared over b squared equals 1. So then I'm thinking, okay, I want to find h, k, a, and b. You guys got any ideas for me? We can find the center. By knowing the location of two of the vertices, or two foci, we immediately know where the center is because it has to be exactly in the middle. So I'm at 3, 0, 3, 6. What's exactly in the middle of that? 3, 3. You could think about like you're basically calculating the midpoint from geometry. Okay, but you can also just like say, okay, the distance from 0 to 6 is 6, so half of that. Okay, and there's my h and my k. So I guess I'll just plug those in right over here. Y minus 3 quantity squared minus x minus 3 quantity squared equals 1, and then I'm still going to have to find a squared and b squared. Okay. Along with finding my center, the vertices are good for finding a. Right? A is the distance from the center to a vertex. It doesn't matter which direction you count. It does matter with a parabola because it was a directed distance to focus, but these have the same distances from the center to the vertex. They're both a distance of 3. 1, 2, 3. So A equals 3. Now, if that was a foci instead of vertices, then that would be C, right? Okay, so I have to pay attention to what information I'm given. Well, now I know A is 3, so that's going to be 3 squared below here, so that's going to be a 9. And the last thing I have to do is try to find B. But that information about vertices isn't really going to help me find B, right? I've kind of exhausted all things I can do with the vertices. So I'm going to switch it over to the other piece of information that I've been given, which are those asymptotes. So I'm going to look at these asymptotes. Y equals x and y equals 6 minus x. Y equals x and y equals 6 minus x. In terms of what I'm trying to find, like I already know where my center is, so I already know h and k, and then I know a is 3. I'm interested in finding b. So when I look back in my notes about what I know about asymptotes, I want to focus on the slopes of these asymptotes. So what is the slope of y equals x? 1. What is the slope of 6 minus x? -1. They should be opposite slopes, right? That's always true for the two asymptotes because we have the plus or minus. Now, on this one, you can think about it two ways. The only way for A over B or B over A to equal 1 is if A and B are the same thing. True? Okay. So if A was 3, then B is also 3. And then I know that I'll put a 9 under there too. Now that's not a circle because of the minus sign. So it has to be a hyperbola. But if that was a plus sign in the middle, it would actually be a circle, not an ellipse. But in a hyperbola, A and B can be the same. Now the other way, like what if it isn't so simple? What if A and B don't have to be the same thing? Then I would go back to my graph and think about, remember, like we would have a rectangle that would do my asymptotes. The diagonals of that rectangle would be my asymptotes. And I just think about it from my center along that rectangle, like what's my rise over run? Well, in this picture, I would be rising 3, because that's A. I went up 3. And then my run I don't actually know. I'm going to run B to get to my asymptote. So when we say that these slopes are plus or minus 1, we're saying A over B. The rise is A, the run is B. So that could be 3 over B is equal to 1, which also gives me the same result that B is 3. So if it's a little less clear, you might have to decide, is it actually A over B or B over A? Well, I can tell in my graph if I just count rise and runs. One of them you'll know, one of them you will not. Okay. Does anybody have any questions about what I did on that example? On that example, I'm doing all the work for you, right? So it's that's not very helpful in terms of preparing for your quiz tomorrow. So what you're going to do for the rest of the period is work through examples with your pods. You can be communicating with people, asking questions, giving ideas out there, so feel free to talk to each other. Okay. I'm going to number you. You guys are going to be 1, 2, 3, and 4. And you can send someone from your pod. I got 4 little piles up there. You pick up letter A. Work it out. Once everybody in the group has one, I'll check it. If it's okay, you'll get C. I did B on the board, so it'll go AC. And then you just work through as many as you can. Go for it.